All right, so now that we've introduced covalent compounds, we're going to look at naming a specific type of covalent compound. Covalent compounds, also called molecules. We're going to name binary covalent compounds, and binary means two. So these are going to be covalent compounds that only contain two different elements. Okay. So we're going to see, as you go through chemistry, a lot of different types of covalent compounds. Some are huge, like proteins. Some are really small, like hydrochloric acid, HCl. And then we got everything in between. And there's going to be different ways of naming these things based on what they are. So when we get to proteins, there's going to be a specific way of naming those. When we get to some smaller ones that are bigger than the ones we're going to look at right now, there's going to be a specific way of naming those. What I'm going to give you now is how we name binary molecular compounds. So, or binary covalent compounds. Compounds that contain only two different elements. Okay. So, when we did ionic compounds, we could name them by their cation and their anion. And if we knew their cation and their anion, we could figure out their formula based on their charges. Right? Because we needed to balance the charges. We don't have that same luxury in covalent compounds. So when we do binary covalent compounds, we have to tell you the elements that are in that compound and then the how many there are. And to tell you how many there are, we're going to use prefixes. So we're going to use these Greek prefixes that have a defined meaning, and we're going to use those in front of the name of the element to tell you how many of each element there are. Okay, so if we look at the prefixes, the prefix for 1 is mono, the prefix for 2 is di, the prefix for 3 is tri, the prefix for 4 is tetra, and so on. And you've probably heard of most of those. The one that's often a lot of people don't hear of is hepta, which is 7, sometimes nona, which is 9, but deca, like decathlon, or octa, meaning 8, octopus, right? So a lot of these we've heard of. So there's going to be kind of 3 simple rules that we're going to follow for naming binary molecular compounds. Remember, binary means just two elements. Okay, and remember, for covalent or molecular compounds, those elements are either going to be nonmetals or metalloids. There's not going to be metals in these. So 3 rules. 1, we're going to use Greek prefixes to designate how many of each atom there are, how many atoms of each element there are. And then 2, in that, there should be another parenthesis there. If the first element, there's only one of the first element listed, we're not going to put mono on that. Okay, we're only going to use mono for the second element if there's only one of those elements. The second rule is that the second element listed, we're going to just end that in IDE. So we're just going to use the names of the elements. We're going to put prefixes on the front of them to show how many there are. And then at the end of the second one, we're going to put IDE. So it's going to end in IDE. And then the third rule, if oxygen is one of the elements and the prefix in front of it ends in an O or A, we drop the O or the A of that prefix. And that's for pronunciation, and I'll show you what I mean here in a second. So I'm going to do 2 examples, and we're going to do more, but I want to do these 2 examples because they kind of show you all the rules. Okay, so this first binary compound, binary covalent, we can see it's 2 nonmetals, carbon and oxygen. So they're going to be covalently bonded, so we have to name it using our covalent naming method. So there's only 1 carbon, but it's the first one listed, so we don't use mono. So we just say carbon. By our rules, we'd want to do mono, but it's the first element, so we don't do mono. So carbon, and then 2 oxygens. 2 is dioxide. So CO2 is carbon dioxide. Notice that this is oxygen. This is one of the elements, but the prefix ends in I and not O or A, so we don't have to follow that third rule. So CO2 is carbon dioxide. Okay? Then we have CO. Both of them there's only one of. So I'm going to do carbon because I don't have to do the mono, or I don't do the mono on the first element. But the second element I do. So if I write monoxide, it looks like monoxide, which we don't do. That's why we drop that O. So it's monoxide. So that the pronunciation is just better. So CO is carbon monoxide. Okay? If you follow the three rules, this is pretty straightforward. So let's do a few examples. N2O4. So 2 is di. And there's 2 nitrogens, so dinitrogen. And then 4 is tetra. But we have oxygen there, and the tetra ends in A, so we drop that A, oxide. And the second element ends in IDE. So N2O4 is dinitrogen tetroxide. Tetra meaning 4. So 2 nitrogens, 4 oxygens. Pretty straightforward. Diphosphorus pentachloride. So I like this because this is easy, right? If you know your prefixes. So diphosphorus, 2 phosphoruses. So phosphorus is P, P2. Pentachloride. Chloride is Cl. What does penta mean? 5. So 5 chlorines. Diphosphorus is pentachloride is P2Cl5. Yeah, when you go that way, it's pretty easy. So SiO2. Silicon is a metalloid, so this is going to be a covalent bond. So Si is silicon. Again, we don't do the mono on the first one. 2 is di. Oxide. So silicon dioxide, because it's oxygen, but it's the second element, so we got to end in IDE. Silicon dioxide. Silicon dioxide is basically sand, and we use silicon dioxide to make glass. Carbon tetrachloride. Since there's no prefix, we know it's just 1. So carbon. Tetra is 4. Chloride. Chloride is chlorine. Cl. 4. Carbon tetrachloride. That looks like crap. Let's try this again. CCl4. There we go. Carbon tetrachloride. 4 phosphoruses. So 4 is tetra. Phosphorus. Remember, phosphorus just has a US, not an OUS at the end. 10 is deca, but it's an A. So we're going to drop the A because we have oxygen. Dec oxide. So tetraphosphorus decoxide is P4O10. Last one, iodine trichloride. There's no prefix in front of the iodine, so we're just going to do I, because we know it's just mono. Trichloride, Cl. Tri means 3. ICl3. Okay? So that's all there is to naming binary molecular compounds. Use the prefix for both of them. Unless the first one only has 1, we don't use the mono. The second element ends in IDE. And if it's oxygen, that's one of the elements, and the prefix for it ends in O or A, we drop that O or A.